Hey, Trans Math class, we are going to start with chapter 5. And in this chapter, we're going to study, we've been studying pretty much exclusively fractions, and now we're going to look at decimal numbers, okay? So we'll start with just comparing some fraction numbers to their decimal counterparts, and then also later on we'll be working with, adding, subtracting, multiplying, dividing decimal numbers. Okay, so to start off, what we've done before is we've been working with mixed numbers. So it says find the missing numbers on the number lines and just see if you can follow the pattern. So we have a couple missing blanks here, and then it's 3 3/4, 4, and then it's a blank, and then it's 4 1/2. And so if you think about it, if this is 3/4, this must be 1/4, 2/4, so you get to 3/4, and then 4/4 bring you to the next whole number. So this would be 3 1/4, and then 3 2/4, and now 2/4 means 1/2, right? And you've got 3 3/4, and then you've got the next whole number. Then you've got 4 1/4, 4 1/2, and so on. Okay, so same pattern here: 5 1/4, 5 2/4. But again, 2/4 means 1/2, so that's 5 1/2. And I've got 5 3/4, and then the next one is the next whole number. So I got 6, and then it's going to be again 6 1/4, and then 6 1/2. So that's a common pattern. When you break things into fourths, if you break it into 4 equal parts, so if I'm starting at 0 and then ending at 1, right in the middle is 1/2, but then the first one is 1/4, and then the second, so then this would be 2/4 or 1/2, and then we'd have 3/4. So that's a common pattern to go 1/4, 1/2, 3/4, and then the next whole number. Okay, so here again, if I kind of count backwards, maybe if I've got 8 3/4, this would be 8 2/4, but I know that to be 8 1/2, and this would be 8 1/4. Okay, so there's my pattern. There's 9, so this is 9 1/4, 9 2/4 again, which is 1/2. Okay, now this one we're counting by tenths. Okay, 3/10, 4/10. This one would have to be 5/10. If I'm going backwards, this would be 2/10. 3 2/10. Okay, now we're going to see, I see that they haven't reduced these ones either, but 3 2/10 is the same as 3 1/5, because I could divide each of those by 2. And then 3 1/10 right here. Okay, and then I've got 3 4/10, and then this would be 3 5/10. Now 3 5/10, 5/10 simplifies down to 1/2. I don't think we're simplifying. We're leaving these in tenths for right now. Okay, so I got 7 8/10, 7 9/10, and then 7 10/10. Well, that would be the next whole number, which is 8. So 7 9/10. Then we've got 7 10/10. That means 8. I've got 8 1/10, 8 2/10, 8 3/10, and then 8 4/10. Okay, here I've got 7/10, so I could count backwards to get these ones. 9 6/10 if I count backwards, and then go backwards again. 9 5/10, and if I go forward from 7/10, I got 8/10, 9 9/10, and then I'm up to the next whole number, which is 10, and then up to 10 1/10. Okay, so start from your given, see what, it appears we're counting by tenths, so then you can just start counting, either if we have this one, we can start counting forward. If we're in the middle kind of here, we could count backwards to get these two, and so on. Okay, so decimal numbers, that's what we're looking at now. And decimal numbers, just like fractions, lie between the whole numbers. Okay, it's just another way to represent fractions is with some decimal numbers. Okay, this one says partition the number line between 10 and 11 into fifths, and then it says show mixed numbers and decimal number names. Okay, so this is in fifths, so this is going to be 10 1/5, 10 2/5, 10 3/5, 10 4/5, and then it'd be 10 5/5. That's your next whole number, which is 11. Okay, now the decimal versions of these. So I'm just gonna write these down. We'll talk about them later. So when you're counting by 1/5, the decimals are 0.2. So it'll be 10.2, 10.4, 10.6, 10.8, and then it would be the next whole number, which would be like 10.10, but that's going to bring you to the next whole number, which is 11. So if you think about it, 2, 4, 6, 8, and then you get to your next, this would be 11.0, right? And this would be like 10.0 if we were thinking in decimals, right? 2, 4, 6, 8, and that's how that would evenly count if you were going with decimals there. Okay. This one's just an example of, I'm not sure why they throw this in here. It's an approximation for, if you've heard of the number pi, 3.14. 22 sevenths is an approximation for that, but it's just kind of thrown in there randomly. So here, when we're counting by, so 1/4, the decimal form of 1/4 is 0.25. I think the easiest way to think of this is with money. If you have a quarter, that's 0.25 dollars, which is a quarter of a dollar, right? So when I count, from here by quarters, right? 3 1/4, which would be 3.25, and then if I had 2 quarters, I'd have 50 cents. So that'd be 3.5 or 3.50. Sometimes I put the 0 in there just so that I'm thinking like with money. 25 cents, 50 cents, 75 cents. And then if I have another quarter, that puts me up to the next dollar, which would be, if I had $3.75, add another quarter, that's now $4, right? Add a quarter, $4.25. Add another quarter, $4.50. Okay. So with 0.25s, just think of money. So $10, add a quarter, $10.25. $10.50. If I add another quarter, $10.75. Add another quarter is 11, $11.25, and $11.50. Okay. Now this one, it looks like the same thing. We've got 6, now we've got a blank, and we got 6.50. So you can kind of see the pattern here. 10, 10.25, so it'll be 6, 6.25, 6.50, 6.75, and then we got the next whole number, which is 7, 7.25, and so on. Okay, now this one's just counting by 0.1s. Okay, 6, 6.1, 6.2, 6.3, 6.4, 6.5, 6.6. Okay, and this one as well, because it goes from 7.3, it skips one, and then 7.5. So that has to be 7.4. We got 7.5, 7.6, 7.7, 7.8, 7.9. Okay, so we're just looking for our pattern there. Okay, this one says use a calculator to change the fractions into decimals. So we could use a calculator, but we could also just use long division. So if we're taking 1 divided by 2, now you can't take a smaller number necessarily divided by a bigger number unless you have to work with a decimal in that case. So what I do is I put a point there, and then I bring that straight up like this. And now I'm thinking this number is 10. So how many times can 2 go into 10? That would be 5 times. And so then I get no remainder, 0.5, 0. It's like 0 in front, 0.5. Okay. 1 divided by 4. If I take 1 divided by 4, okay. Well, I'm going to do the same thing, put a 0 there. Well, I know that 4 can't go into 1, so that's 0 times. So I think 4 goes into 10. I know that that's 2 times. I'm going to put the decimal right there. 2 times 4 is 8. Remainder of 2, and then I bring down another 0. 4 goes into 20 5 times. And then that's it, 0.25. Now these are going to be common ones that you just need to remember. 1/2 is the same as 0.5. 1/4 is the same as 0.25. So 3/4, okay, 3/4, think about this. 1/4 means a quarter. A quarter is 25 cents. 3/4 is going to be 75 cents. It's going to be 0.75. But let's just divide it out and see. So if I divide 3 by 4, well, I know that 4 can't go into 3, so I put 0 there. So can 4 go into 30? Yep, 7 times. 7 times 4 is 28. And I subtract, I get 2. I bring down another 0. 4 goes into 25 times, 0.75. So those are ones that you want to remember. 3/4 is 0.75. 1/4 is 0.25. 1/2 is 0.5. Okay, now anything that's over 10, that one's really easy. All you have to do is put the decimal in front of it. If it's a 6 on top, it's 0.6. If I had 7/10, that would be 0.7. If I had 8/10, that would be 0.8. If I had 9/10, that would be 0.9. So that pattern's real easy. If you're dividing by 10, it's whatever the numerator is with a decimal point in front of it. Let's skip over that. Okay, it says use a metric ruler to make 3 triangles, label the parts. We're not going to measure them, but we can draw these approximately what they're saying. It says, so draw a triangle where each side must be a different length, right? So I'm going to use this little line thing to make some straight lines. So if I want them to be each a different length, I'm going to make that one pretty long, make this one kind of shorter, and then this one's going to be the longest one of all, right? So there's something where they're all a different length, right? Shortest, and then here's the next longest side, and then this is the longest side right there. Right. And I'm not using a protractor to measure these angles, but I mean, we could say, if I wanted to talk about these angles, you know, I could say that angle is acute because it's less than 90. This angle right here is obtuse, and then this angle here is acute again. It says 2 sides the same length. Okay, doing triangle with 2 sides that are the same length. So if I was going to do that, I might get a triangle that looks kind of like this, maybe. Something like that. Yeah. Close enough, I guess. But what I was trying to do, let's try that again, because I may have made all 3 sides the same length there, which I didn't want to do. Let's see, how do I erase this? Maybe I can just go like this. Let me try this again. I'm trying to make it a little bit skinnier. Something like that. Okay, well, pretty close. All right, so if this side and this side are the same, you know, then I have 2 sides that are the same length. Okay, that's good enough for that. And then here, a triangle where all sides must be the same length. I'm just going to see if I can freehand this. So if I was going to do all sides the same length, I would have something that looks like this. And if that was the case, each one of these angles, since they have to add up to 180, they would each be 60 degrees. And then each of these sides would be the same. Okay. All right, that is it for this first section.